Alright, welcome to video number 2, where we'll do 9 through 16. Again, I've broken the video into thirds so that maybe you can more quickly find whatever problems you're looking for. Number 9. The figure shows the graph of the function f in the xy plane. The function f is either a sine function or a cosine function. Okay, remember, because every sine could be identified as cosine and vice versa. Consider an angle in standard position in another xy plane not shown. The terminal ray of the angle intersects the unit circle at point P. Which of the following is true about the relationship between F and P? Okay, goodness. F gives the vertical distance of P from the x-axis. Okay. Okay, well, if theta is... Yeah, if I don't want to deal with phase shifts, then I'm calling this a sine. I didn't say, it said it could be either one, but I'm going to call it a sine because that seems to make more sense to me. The sine of an angle tells you the height of an angle. Or it tells you not the height of the angle so much, but the y coordinate of where it intersects. So here's my angle in standard position on this plane. Intersects the unit circle, so that matches. This height is 1, my maximum height is 1. So F is my graph of F, gives the vertical distance. That sounds like a sine thing. Horizontal is a cosine thing. Vertical distance versus vertical displacement. Okay, I'm throwing horizontal out. I'm not worried about that. Distance is always positive. Displacement could be positive or negative. So I can have negative here, I can have negative here. So I think I better go with displacement rather than distance. Number 10. Function P is given by this. What is the period of P? Oh, we like this one. This is a straightforward one. As long as you remember that the tangent period is pi over b. So pi over 2. So keep it, change it, flip it, or just know how things work. Whatever, you get a period of 2. Number 11. The graph of the sine function is given in the xy plane. Okay, so the sine function, its period is a little messed up, so, or at least it's not the normal period. What is the length of the largest interval of input values of f, input values, so x values, on which an inverse function of f can be constructed? Okay, so we talked about this, making an inverse. That's where, for an inverse, you need f to be 1 to 1. You need f to be 1 to 1. So I would go from 1 to 3. That looks like a good spot. I mean, again, that wouldn't be our normal inverse sine function, but for this particular function, that would be 1 to 1. So it passes the horizontal line test and the vertical line test. Now, let's make sure we answer this question correctly. What is the largest interval? So it didn't ask what the interval is, it just says the largest interval. So I'm going to go from 1 to 3 and say that interval is 2 wide. I guess the trick would be you could pick an interval that's 0 to 1 or 3 to 4, and those could have inverses, but those would not be the widest interval. So answer choice B. Number 13, table problem. Table gives order for 5 points from a larger data set. The larger data set can be modeled by a sine function with a period of 4. Okay, so that's nice. They gave us a full picture here from 0 to 4. The maximum values of the data set occur at x values that are multiples of 4. Okay, so the max is 5, or 0. Which of the following best defines f of x for the larger data set? Okay, so basically make an equation that fits this. I'm looking at my choices. They're all cosine. Cosine starts at a max, so I shouldn't have any phase shift going on. So let's see, I'd want to start at 5 and end at 5, and my minimum is 3. It's as low as it gets. Oops, not that 3. That would be 2, that's 3, that's 5. So I know it looks like that. So already I'm thinking amplitude is 1. That throws out a few of them. So what's the difference here? Vertical shift is up 4. That's true of all of them. Like the midline is 4, but that didn't really help. So it's about the period next. They just flat out told me the period was 4, so I can narrow these down. Period is supposed to equal 2 pi over b for cosine. So if I cross multiply and then move things around a little bit, I get b equals pi over 2. And that matches answer choice A. So fitting an equation to data points. Definitely need to be able to do that. Number 13. Function is given by this thing between negative pi over 2 and pi over 2. Domain and range of the inverse function. Oh, the inverse function. Okay. So negative pi over 2 to pi over 2. I'm first just going to graph this, and then I'll worry about the inverse. So normally sine, I kind of have to graph the whole thing before I can graph half the thing. So 1 and 1/2. So there's my graph 0 to pi, but I only want to go pi over 2 to negative pi over 2. Okay, so this makes sense. I only want to go from there to there. That would have an inverse because that's 1 to 1. So I could either erase the rest of it or scribble it out or whatever. So I want this portion of the graph. The domain and range of the inverse function. Okay, well, of the function, my domain is negative pi over 2 to pi over 2. The range is negative 1/2 to 1/2. Now here's a fun little thing, because to do inverses you switch x and y. So if I switch x and y, that means the domain and range trade places. So the range of f becomes the domain of the inverse, negative 1/2 to 1/2. That looks like A. The domain of the original becomes the range of the inverse. So negative pi over 2 to pi over 2. So that looks like A. So that was kind of tricky one there, but you had to know about x and y trading places. Number 14. The figure gives the graphs of 4 functions labeled A, B, C, D. Oh, goodness, what a mess. Which is the graph of the inverse cosine of x? Okay, well, I gotta back all the way up here. Let's see, to cosine. So there's what cosine, that's what cosine looks like. Inverse cosine, we'd have to stop here in order to be 1 to 1. So there's my normal graph of cosine. So again, that's cosine. So next I'm going to graph inverse cosine. So I got to switch my x's and y's. So my x's go from 0 to pi, which now means my y's are going to go from 0 to pi. And my y's went from negative 1 to 1, which means my x's are now going to go from negative 1 to 1. So let's see here. I'm just going to pick out a couple of key points. The point 0, 1 was on the original. Again, this is how I avoid memorizing what the graphs of the inverses look like. I'm just going to kind of manually do it each time. So if that's a graph, if that's on the graph of f, then on the graph of the inverse it would be 1, 0. Yeah. And here's another key point. That would be at would be at pi over 2, comma, oops, that would be at pi over 2, comma 0. So on the inverse would be 0, comma pi over 2. You keep your x's and y's straight here. So 0, comma pi over 2. And then this last point on the original graph is pi, comma negative 1, which means I'm at negative 1 pi. 1 pi is up there. And you know, it's going to have some crazy like curve to it. I don't think it's going to look like cosine. I think it's going to look more like that. But I'm multiplying by 2. So this is the inverse cosine. So I just need to stretch it out and stretch the peak up to 2 pi. And so that looks a lot like this graph. That's the only one that gets up to 2 pi. So which graph is that? It's not the little dots, and it's not the solid one. So is it B or is it C? I think it's C. C looks a little bit lighter, B looks a little darker, so I think that one's B. I think this one's C. On the test, it's not that hard to tell things apart on a question like this. So question C. Now, if you're good, and if you have it all memorized, maybe you know what the graph looks like before any transformations, and you just automatically know that that's the inverse cosine graph, and so all you have to do is stretch it by 2. That would certainly be quicker, but I don't really have that memorized. Instead, it didn't take me a little too long to start with cosine, build inverse cosine, and then jump to the answer. Number 15. Figure gives a right triangle. Y is the length of the opposite side of angle A. Yes. If the function f gives values of A as a function of y, which of the following could define y? Okay, so it's like, which of these makes sense? Cosine of y over... No, this isn't right. If you're doing cosine or sine, you need to be doing that of an angle. So this isn't right. You don't take the cosine of a ratio. The cosine gives you a ratio, the sine gives you a ratio. So let's see, inverse sine is opposite over hypotenuse, so that looks pretty good. Inverse cosine should be adjacent over hypotenuse, so that's out. Okay, so it's got to be D, because you never take the sine or cosine of a ratio. Sine and cosine is of an angle, which gives you a ratio. So it's got to be D. Number 16. Function f is given by that thing. X is between 0 and 1. Which of the following gives the inverse? Okay, so inverse means maybe it's easiest to just switch x and y rather than thinking about the graph. So inverse means switch places. X equals 3 cosine of pi y. And then let's solve for y. And if I have to worry about... Oh, I won't have to worry about those because they're all the same. So even if I'm not sure how that that domain of the original turns into the domain of the inverse, it kind of doesn't matter because they all match. So it's got to be right. All right, so let's divide by 3. Then let's inverse cosine both sides. Equals pi y. And then, let's see. Yeah, inverse cosine both sides. Whoops, how did that get over y? Said the right thing, wrote the wrong thing. Equals pi y. So let's divide by pi. So 1 over pi inverse cosine x over 3. Sure hope that's one of my answer choices. 1 over pi inverse cosine x over 3. There it is. And again, this is the domain of the original, which means it should map to the range of the inverse. Another way to phrase that is, if I could find the range of this guy, it would be the domain of the inverse. But they all match, so I didn't really have to worry about what that looked like. All right, that's in video number 2. and see video number 3 for 17 through 24, or video number 1 for 1 through 8.